Now, what about the velocity of this wave? We call this is a spherical wave. What about the velocity? What about the velocity? The velocity how can we get the velocity? Euler equation. Okay, from Euler equation, S says dP dr minus, that has to be balanced by rho 0 dP dt. Is it correct? No. This has to be velocity in our direction. Okay? So this is dP dr is a, wow. Now I have 1 over r as well as this. I have to be very careful. So I'm differentiating 1 over r, and I have a minus over here. Differentiating 1 over r will give me minus 1 over r square. Okay, that is this induced by this term. Parenthesis. And then I have to differentiate this with respect to r. That gives me what? 1 over r, and I have minus k minus j plus jkr. So I have plus jkr. Okay? And then I have exponential minus j omega t minus kr. Okay? There is a big chance for me to make an error, so anybody pick up error, you will get a partial credit. That has to be equal to rho 0 dur dt. Therefore, I got the velocity in our direction has to be, I have to divide this rho 0, and here I have exponential minus j omega t minus kr. And I have minus 1 over r squared plus jkr over r, and then I have to integrate this one with respect to time. That gives me what? 1 over minus j omega. Okay? And then I have exponential minus j omega t minus kr r. So I have velocity. And when I look at this velocity and this pressure, first thing I can immediately see is that this pressure and this velocity is no longer in phase. Right? For plane wave, the velocity, if I calculate, would be what? A, because the impedance of plane wave would be rho 0 c. Yeah? Impedance of plane wave in the duct is rho 0 c. So impedance of this plane wave, what would be the impedance of this plane wave? rho 0 c. So that will be a over rho 0 c exponential. That is the velocity. Therefore, right? Therefore, the pressure and velocity of plane wave is in phase, always, rho 0 c. But as you can see here, pressure is A over R type, but the velocity is real, has a real part and the imaginary part, right? And that real part and the imaginary part depends on R as well as K and omega. It's complicated. The impedance of spherical wave. So let me summarize the impedance of a spherical wave. So impedance of spherical wave is rho 0 c, as you can see in the text, kr square 1 plus kr square plus imaginary part kr 1 plus kr square, and that has to be minus. This is the impedance. Wow, that's very interesting. First, it depends on kr. Okay? What does kr means? K is 2 pi over lambda. So kr actually measures the distance from the origin with respect to wavelengths. So this is the origin, and the wave is propagating omnidirectionally. And for example, this is 60 centimeter from the origin. 60 centimeter does not have a meaning.